Hello there. You may notice that today we are not in the IP Nexus studio. I am excited for today. We introduce the Inventor and Innovator episodes. I am Marifa. Stick with me. I promise it will be interesting.
As you know, IP Nexus has always been about stories, real experiences, real journeys through the world of intellectual property from different IP practitioners. But today, we're taking things a step further. We are thrilled to introduce a new chapter of the IP Nexus, episodes that bring you closer to the innovators and inventors. By the way, I am Wazo. We'll be diving deep into their journeys, giving you a front row seat to their challenges, successes, and everything in between. These are the people who've dared to dream, to create, to solve problems, and to change the way we live. Theirs are stories are about resilience, about the process of turning an idea into reality, about navigating the often complex world of intellectual property while keeping the fire of innovation alive.
And here's why this matters to you, our listeners. When you hear these stories, you're not just learning about inventions, you're learning how innovation happens in the real world. You'll gain insights into how these brilliant minds protect their ideas, how they collaborate, overcome setbacks, and ultimately bring their products to market. So, get ready to be inspired. The Inventor and Innovators episodes will not only take you into the world of IP but also into the heart of what it means to innovate. Because at the end of the day, innovation is more than just an idea, it's a journey. And we're here to walk that path together. Stay tuned, and as always, thank you for being part of the IP Nexus community.
So today on the IP Nexus, we present a brilliant biomedical engineer, who is no stranger to the process of invention and innovation. Today we are doing things a little differently. We were not able to fly to where our guest is, so we asked her to respond to some questions we had sent her earlier. I am so excited to present to you today on IP Nexus, Ms. Brenda Nakandi.
Hey everyone, it's Brenda here, and I am so excited to be on IP Nexus today. Right now, I'm actually finishing up some grocery shopping, just grabbing the last few things for dinner tonight. You know how it is, multitasking. But don't worry, I've got the questions that Wazo and Marifa sent me, and I'll be diving into them as soon as I get settled. I can't wait to share my story with all of you. So stay tuned, I'll be back in just a bit. My education background is in biomedical engineering. I did my Bachelor's of Science in Biomedical Engineering degree at Makerere University, and then I further went on to do a Master's in Biosciences and Bioengineering Innovations in Precision Medicine that was in Europe, and then another one in Biomedical Engineering at Case Western Reserve University. What really inspired me to pursue a career in biomedical engineering is that I was and I have always been passionate about physics and generally the metaphysics of life, like why something is really the way it is. Oh, here's my bus. The one thing that I know is that I've always been curious. Back when I was in level, the idea that, for you to be able to see, light has to shine on an object, but this object will appear inverted in the retina, that is that part of the eye where the image is formed. And then somehow the brain comes in to let you know what it is regardless of how it forms onto the retina. And then because of that, someone used this principle to actually design the camera, which is all around the idea of light, how it bends and stuff like. So just the fact that that is possible, the fact that that is the reality of things in this beautiful universe, that really sparked my imagination, and I think that's what got me onto the journey of doing something in regards to physics and biology. But also with our education system in Uganda, somewhat it's your grades that define what you do at uni, and so for me, because of the subjects that I did, which were physics, biology, chemistry and additional mathematics, I saw myself doing something either related to medicine or engineering. Initially, I didn't really know about the biomedical engineering course, but I was told at that time that it was a new course and that it was really good. It sounded to me like something that I would be down to do, and voila, it's what I was admitted to do, and so I started to attend classes. Oh, look at the time, let me get dinner started. Dinner is cooking, so, where were we? Oh yes. The course itself had co-curricular activities in form of collaborations. I was inspired by collaborations that were aimed at bridging the gap between health and engineering, and so I found myself joining these clubs, and one of these clubs was under the Uganda Case Western Reserve University Research Collaboration. This is actually where the idea of the vaccine career, the innovation that Wazo knows me for, came in. This collaboration involved having students and lecturers from the two universities brainstorming ideas about how to solve Uganda's problems using figure technology. The collaboration itself is big, and it was started way back before I was even born, I think 1986, and it was really to stop the AIDS epidemic, which was then, I think, a big thing those days. Within the biomedical engineering collaborations, some of the teams that we had include the waste management team, the vaccine cold chain team, and then we had the pulse oximetry redesign team. So of these teams, for me, what really felt like my calling for some reason was the vaccine cold chain. The vaccine cold chain team was working on a number of products, including redesigning the vaccine carrier and bags that were intended to be carried by health workers to go for outreaches as they carried out vaccination. The idea of redesigning the vaccine carrier picked up really fast, and so I was keen to see it grow, as this was my team's project. I appreciate the mentorship that we got from Dr. Robert Sakitoleko, and I think this is one of the main reasons why we actually pushed further as a team. Health workers traveled long distances to carry out vaccination in rural areas in Uganda, and in addition to this, different vaccines require different temperatures to stay viable. The health workers are supposed to carry vaccines which they use to conduct immunization through whatever distances they go to, say for example 12 kilometers. The designs of vaccine carriers then were such that one was supposed to add an ice pack within the cooler of the vaccine carrier. For some reason, this puts some vaccines at risk of losing their potency because some vaccines require lower temperatures than others. So it meant that sometimes, when the cooler has to be opened, the health worker has to actually throw it away, some vaccines, because once opened they could not be returned back because they had been exposed to too high temperatures. And so we started thinking, what are the chances that on opening some vaccines lose their potency and things like that? So in trying to tackle this whole idea of making sure that every child actually gets to be vaccinated, it's what led us into going on with our intervention. So we continuously kept in communication with the health workers and eventually produced prototypes using the whole idea of human-centered design, and that's how we managed to get onto the version of the vaccine carrier that we applied for patent protection. I have to catch up with some work right now. Let's continue the conversation later on. Good morning from this side of the globe. I am heading out to meet some friends, so let me answer this one before I get going. I think I wouldn't have solved the problems that I solved if I hadn't undergone through the courses that I went through a while as student in biomedical engineering. I also believe that having a curiosity as to why certain things work the way they work influences my approach to problem solving. Basically, sometimes it's about having a set process, other times it is more intuitive. But the whole point is that having to undergone training to understand what biomedical engineering is about, it is always at the back of my mind that I should merge both healthcare and engineering, and specifically using engineering solutions to solve healthcare problems. In the case of the innovation I had described earlier, we wanted to make sure that every child actually gets vaccinated at that time that they ought to get vaccinated. It became a situation of figuring out how can we do that in a country like Uganda where it's a low-resource setting. It meant that we had to use the most frugal of all technologies. Imagine your cabinets at home. You have different sections. You may have a section that is divided into shelves, and you know that this is the section that has to hold spoons and forks, whereas another section may be for holding cups and plates. Now imagine knowing that a certain section should hold the spoons and forks because of air B, C, and D. This is how we arrived at how we were going to implement on our vaccine carrier. We did it that way because we knew that a certain vaccine A should be in such a spot and therefore should be held in a particular position. So in summary, I approach problem solving the way that I do, because of my training and curiosity. Now, come on, let's get going. This is my friend Michelle. Say hello to the IP Nexus friends, Michelle.
Hi IP Nexus friends. I'm Michelle. I just popped by to say hello, and now I will get behind the camera.
So to answer the question of whether intellectual property was important to me when I started my journey as an inventor. Well, in the beginning, I did not know much about IP. IP became a thing for me after attending some carrier guidance talks and through some hosted lectures by experts at my university, but besides that I really didn't know that you can actually protect an idea. So when we actually got a utility model for our vaccine carrier, it became more or less like a huge milestone for us. It felt like a marker of success. We had competitors as well, and so we chose to protect our invention considering how far we had gone and what we were looking at in order to be able to continue with what we were doing. Don't get me started. It was tedious. I honestly feel like that process was a learning process in its way, very tedious. When we initially decided to file for a patent, we quickly realized that you don't just go for a patent without doing some groundwork. At that time, one of our colleagues was in the advanced stages of getting a patent for her own invention. From what we saw with her, it was a lot of work. She was taking the international route for protection. Based on her experience, we decided to first focus our efforts to protect our invention in Uganda before we actually go global. Also, we decided to opt for a utility model mostly because it was easier, cheaper, and we were set on setting a standard for other inventions that we're going to protect later on. We decided to go down the journey of utility model also because we didn't really have a lot of expertise regarding how to prepare the specification document. Somehow, with consultations from people from Uganda Registration Services Bureau, URSB, we were able to register our utility model. Although it was tedious work, I would say I'm glad I went through it because now I know better. So we are back, and look. We are in a studio. My friend Sarah has arranged this so that I can finish up the remaining questions in style. Sarah, read out the questions for me.
Cool. The first question is, Do you think IP is more of a barrier or a nebula for young inventors in your field, and if so, why?
I feel like IP is one of those markers of growth. Having an IP gives you that confidence to keep pushing and go ahead and see where it takes you. In Uganda, just the fact that we are in a low-resource setting makes people think that IP is not really worth the investment. But for someone who is interested in seeing where their product is going, IP is important. Plus the fact that when you need funding, it's one of those things that you want to tell your funders you have to attract more funding. So to me, IP is more or less like a marker of success and a tool that pushes you forward.
The next question is, how has securing a utility model impacted your career and your inventions journey?
As I had said earlier, getting the utility model set a standard for me, which has enabled me to consider IP registration as a mandatory step towards commercialization, as that's a required milestone for funding as well. Also, by going through the process the first time, I've gained this experience and I use that experience for all the grants that I've applied for. There was a time in my career I applied for a grant to support one of the innovations that I was working on while I was still a student, and one of the things that I had to do was to make sure that I get IP registered. Because of the experience that I had, it was easier to go through the process of securing an IP that time.
Did securing IP protection change how you approached commercialization or the relationships you build with industry players?
When you understand the process of commercialization, including who you are supposed to talk to in order to get something done, you quickly realize why you need IP. In our first prototypes, we used wood, but if we wanted to use plastic, we knew we were not just going to go to China to tell them to produce for us whatever we wanted. It would make more sense to first protect any IP before engaging such manufacturers. Protecting your IP is a good thing. In fact, it gives you the confidence to go on and reveal your product to the manufacturers because you know it's not going to be stolen.
Is there anything you would have done differently in terms of IP protection?
I think that I would have been taking classes on how a patent document is prepared and getting myself aware of the patenting process in Uganda.
What advice would you give to the young inventors, especially in the moment of field, who are considering protecting their inventions through IP?
Do not give up. Do not give up, because it's actually very rewarding. Once you get that certificate, it feels good, and then make sure to include it on your CV. So don't give up. I would also advise them to invest some time in knowing the right people and the right offices to go to, because it makes the process smoother.
What are your hopes for the future of your inventions?
Right now we are trying to look at producing our innovation from China, so I think that's where the future is, and hopefully then we can get even more prototypes and give to people and uncover their perceptions and gather their recommendations for improvements.
What's next for you? Are there new inventions or products you're currently working on that you're excited about?
I've just finished my school and I'm currently figuring out my next steps in relation to my qualifications in biomedical engineering. There was this one project that I was working on that was my design project while I was in uni, which is a spinal brace. We're trying to get IP protection for it as well, but things get a little bit harder when you're out of the country. There are many things that I'm really excited about and seeing where my journey goes, because biomedical engineering has been such a beautiful journey for me.
Brenda, that was the last one. It's a wrap.
Awesome.
We hope you enjoyed this episode with Brenda on IP Nexus as much as we did. See you next time.
See you next time.